Alright, so this is lesson 3.3. We're going to be proving that lines are parallel. So make sure that you have the header at the top. We'll go through really quick on this one because we used a lot of the stuff that we did in our last lesson on 3.2, and so we should be able to get through this one pretty quickly. So our objective today is to determine whether two lines are parallel. Alright, so the first thing that we're going to write down is we're going to write down the converse of corresponding angles theorem. So we're going to write down here, right here, and we're just going to write down one picture. So draw this picture down once and label it. Label this one 1, 2, label this 3, 4, 5, 6, 7, 8. So you just have to draw this picture once, and then we'll use that for there. So we talked about in our last lesson 3.2 about corresponding angle theorems. Now this is the converse. So remember, our converse is we have if P then Q are conditional, and remember our converse is just switching those. So all we're doing is we are switching. We have our if then statement. So our converse from the last one is we're just switching it up. So we say in this case, if two lines and a transversal form corresponding angles that are congruent, so 2 and 7 are corresponding angles and they are congruent, then the two lines, line L and line M, are parallel. So we're just doing the converse of all the theorems that we did last time. Okay, so make sure you have that written down. Alright, and then we have the converse of alternate interior angles and theorem, and the converse of same side interior angles. Again, you're going to write this. So all we're doing is we are taking our theorems that we had before and we are just switching and making the converse statement. So in this case, if two lines and a transversal form alternate interior angles, then the two lines are parallel. Okay, so you don't need to draw this example over and again, but just make sure that you say have like the angle 4 and angle 6, then the two lines are parallel. Same thing with the converse of the same side interior angles. If two lines in a transversal form same side interior angles that are supplementary, then the two lines are parallel. So, and then our next one that we're going to have, we're going to write this one down too, the converse of alternate exterior angles theorems. Again, write it down. If two angles in a transversal form alternate exterior angles that are congruent, then the two lines are parallel. So before we were given that if the two lines are parallel cut by a transversal, then the two angles are congruent. Now it's just the opposite. So we're trying to prove that the two lines are parallel, and we use that using our converse method. Alright, so and then the last thing that we have here is the proof of converse of alternate. So when we are proving our converse, it sometimes can look different than the other proofs that we have. So far we have had proofs mostly in the 2-column. We also talked about paragraph, how we can have proofs in a paragraph form. Not as neat in the paragraph form, but really like the 2-column. But a third proof that we can have is called our flow proof. So all you need to write down right here is flow proof are arrows that show logical connections between the statements. Alright, and so we're going to do one example right here. So this is going to be problem number 1. Alright, problem number 1, and you're going to write this down. So remember, we just said right there that the converse of alternate interior angles theorem said that these two angles right here, because they are alternate interior angles, that theorem says that these two lines, line L and line M, are parallel. Okay, but we remember theorems are different than postulates. Postulates are given truths. Theorems we can prove. So let's do one example of a flow proof proving that these two lines, line L and line M, are parallel. So we are first given this, that angle 4 and angle 6 are congruent. So our flow proof would look like this. We'd have angle 4 is congruent to angle 6, and that was given. Alright, so looking at this picture right here, we know that these two angles, 2 and 4, are across from each other, which means that they are vertical angles. So we know that angle 2 is congruent to angle 4, and that is our vertical angles. Whoops. Vertical angles are congruent. So let's erase that. That should be angles. So vertical angles are congruent. Alright, so our flow proof is going to have arrows. So we're going to have this was given, and we have vertical angles are congruent. 2 and 4. Do we see how these, we both have 4 and 4 right here. So remember our transitive property. Our transitive property is if they both are congruent to 4, then I can put angle 2 and angle 6 together. So I can say angle 2 is congruent to angle 6. Because if they're both congruent to 4, then 6 and 2 are also congruent. So if 2 and 6 are congruent, then we can say right here, another arrow, we can say line L is parallel to line M, because if corresponding angles, we'll say, if corresponding, we'll just abbreviate, corresponding angles are congruent, then L is parallel to line M. So we worked back, we said that if these two right here are congruent, then it must mean that these two lines are parallel. And that's exactly what our alternate interior angles are saying. 4 and 6 are alternate interior angles, which means that they are parallel. How do we prove that? Because we proved that 2 and 6 are corresponding angles and that they are congruent. So if those two are congruent, it must mean that the two lines are parallel. So our flow proof is just a little bit different, where we have arrows going from one to another. But if you can just remember our alternate interior angle theorems, then the converse is just switching it. Remember, our converse is just switching if our hypothesis and condition, our hypothesis and conclusion, remember, it's just switching the order, our if-then statements. Okay? Perfect. See you guys soon.